get into the big topic of open source, something that we actually say at Red Hat.
This is so awesome.
We are an open culture that believes in
What is that process that a developer, or let's say
as the Kubernetes ecosystem really boomed? Hey, Randy, I think we can. Yeah, we can't hear you. Hey, Randy, can you hear us?
one more time.
Oh yeah, that was good.
Yeah, so let's try it again. Good morning. Good evening. You've made it to the Level Up Hour. I've made it to the Level Up Hour too. We have a great episode for you today and a great guest. We have Daniel O, who is the Senior Principal Developer Advocate. And Jafar, what is Daniel going to be talking about today?
That's a good question. I actually have no idea what this Quarkus thing is. So I think he's gonna tell us a bit more about that. So
Right,
Daniel,
so-
thanks for joining us and
Yeah, for sure.
introducing
Yeah.
this great topic.
Yeah, for sure. Yeah, thanks for inviting me, and thanks for having me, Randy and Japar. So yeah, once again, my name is Daniel O. I'm a developer advocate and technical marketing major at Runtime's team at Red Hat. So Quarkus is Kubernetes native Java framework. So you probably know, if you have any experience of Java application development before. So people say Java is pretty old and too heavyweight to run application on Kubernetes. But the answer is yes or no, because the Java and the similar relevant Java framework were born for Kubernetes. It's almost 26 years ago, and 27 years ago, Java was born. And then the large language platform tried to fit it in the Kubernetes workload, like optimization and lightweight and the scalability, electricity, a lot of stuff thing. And the Quarkus was designed to fix that the old Java framework problem, high performance and a small memory footprint and a super fast startup and response time, because the old Java framework was designed for like a bare metal virtual machine rather than container environment. And the Quarkus was born after Kubernetes, which means we definitely consider about Kubernetes stuff. So all the feature, benefit, and the value of a Quarkus, we 100% support the Kubernetes native stuff. So this is the Quarkus stuff. I'm gonna reveal more fun stuff today with a live demo. So yeah, it should be fun.
Oh,
Sounds great.
that's very nice. Thanks for this nice intro. And so, in fact, yeah, if we look at some of the most recent languages, when we talk about these new technologies like Go and Node.js, they appear to be like more fit for or better fit for these cloud native type of applications that require scalability, etc. But as you say, thanks to Quarkus and the engineering effort that have been made, Java is still relevant as a language for those type of workloads, except that instead of having to own the or acquire that experience with new languages, or well, not necessarily new languages, but I mean Java has been here, relatively new in the enterprise world, at least. So you can have your Java experts, but they are now more relevant in the Kubernetes native ecosystem and such things.
Well, so I mean, there's a huge JEE footprint out there in the world, and a lot of developers conversant in that. But there's that on ramp that's needed from the world that once was to the world that everybody wants to get to now. And I sort of interpret Quarkus as that on-ramp that allows that huge Java installed base to get to a newer framework, a newer way of doing things. Would that be a fair statement?
Yeah, absolutely. Yeah, absolutely. I 100% agree with that. So there are more than 15 million Java developers out there, like around the world, and they actually working, developing new application for business requirement every single day. We cannot ignore them. Even they have to deploy existing application or a new Microsoft application on Kubernetes, they still want to keep their career path with their own skill set rather than, okay, you got to go to run JavaScript or Go program language. That should be big burden for them, big challenge for them. So if we could let them keep using their own Java skill set, not just only for existing application, but also new Microsoft's application on Kubernetes, it would be fantastic. That is the ultimate goal we design Quarkus, and then there are so many company and individual contributor jump into Quarkus open source project and then make it better every single day.
That's really nice. And so if we look at so you spoke about like the old ways of creating applications. We tend to call those like legacy applications, but we know that there are some new types of architectures like microservices based architecture, event driven, serverless, and this type of new new approaches or new architectures. Can you tell us a bit more about how Quarkus fits into this new era of these new types of architectures?
Absolutely, that's a really good question. So I gotta, so this week actually I'm staying in DevOps Poland, and the first day the DevOps Poland I already spoke a lot of developer. It's 100% genuine Java developers. So they really concerned about like event-driven application as well as serverless on Kubernetes. So previously Java framework. So for example, Spring Boot, and if you wanted to develop reactive application for event-driven architecture, you might need to use Spring Reactive, which means a totally different architecture and API, bunch of stuff. You need to learn something new, or you need to rewrite existing application. Even you still provide the same business capability, but they should be handled by reactive and event-driven application. So this is one of a big burden for Java developers. And the Quarkus provide very flexible features and dependency and extension. So for example, Quarkus was born based on reactive programming, but still Quarkus allows developer to have the imperative application like just request response to HTTP protocol, etc. But if you just add one single annotation like incoming, outgoing, and then your Java method will be handled by reactive application automatically, because behind the scene, Quarkus will take care of that kind of stuff instead of developers' hands-on stuff. And also, when you packaging your application as a container, like a Docker or a Podman, and they deploy to Kubernetes as serverless, or you just deploy to Amazon Lambda, and then each star maybe 5 seconds to start up as part of the core to start strategy. It takes some time, which means your end user, oh, I don't see any web content, like just white blank page. Oh, it's sometimes something happening in my server. So it kind of some incident. So in order to fix the problems, the Quarkus provide two feature compilation to the developer. One is just creating job file like running on JVM. The other one is the Quarkus enable Java developer to have a native compilation, which means you just created executable file like an exe file on Windows Server system, and they're just running on it without JVM. But big benefit from native compilations, you have a super fast startup time. I'm gonna just try to showcase in my demo just a little bit later. And then the memory footprint is super tiny. And then end user perspective, they even cannot recognize my application actually scaled down and scaled up immediately. So you maybe get rid of your cold start problem, any serverless platform like Amazon Lambda, Azure Function, or on-prem Kubernetes Knative.
That's a very nice feature, and I'm willing to learn a bit more and see how it works during the demo. But so if I understand correctly, what you're saying here is that we can have. So is it the same code base that we can run in different ways? So one being run in a traditional JVM, but still having smaller footprint, than a Java traditional application, and we can choose to have it as a native executable that is compiled as a binary. But it's the same code base, or does it require adaptation somewhere to
Yeah,
have that?
it's totally same code base. So
Okay.
there are a couple of tools like a Maven or Gradle or Quarkus CLI. So you
Hmm.
just pass down one parameter like a dash dash native, which allows you packaging same source code to different artifact like a job file on JVM or executable file for native compilation.
Okay. And so you're gonna show us those things,
Absolutely,
I
yeah, I'm
guess.
more than happy to do.
Okay, cool. And so what does it use? Um, so yeah, I think I know the answer, but maybe it's good to explain what technology enables this native compilation, and what's the difference, I would say, between a traditional compilation that is targeting JVM and anything that we strip out
Yep.
when doing binary compilation, for instance.
Yeah, so I'm going to repeat it, that kind of answer during my demo, but here's a quick short
Okay.
answer. So in a traditional way, you're going to just packaging the job file and running on JVM based on just-in-time compile strategy. So
Hmm.
you just create a job file, like an immediate code and running on JVM, and then, but the native compilation, we took different approach to compile application based on ahead of time build strategy. So we put in the all kind of dependency library and all kind of stuff. Just like imagine really similar concept when you can create a container image. You can put in the all required thing like application and runtime or some dependency. You can package in one image file, and then you run that image in any container platform from your local and the remote Kubernetes, even AKS or EKS, because your container is already has all required dependency and runtime application itself. So we got to do a similar thing in the when you packaging native executable file. We put in the all kind of stuff, and then running on Grab VM technically is substrate VM to run that application. Is totally different thing. Uh, the general Java virtual machine, and then
Yeah.
this is a big different thing in native compilation versus the traditional Java jar compilation.
Okay. Okay. Cool. So yeah, so what it does basically, if I understand correctly, is that instead of having things happen when the application is running in the JVM with things like dynamic class loading and stuff like that, it's
Yep,
happening ahead of time during the build, and we are optimizing the dependencies. Everything is put in there,
yep,
and once the application is running, it's only like 100% efficiency. There's no, oh, I need this, and then I'm gonna pull it, etc.
yep. That's correct.
Okay, very good. All right. So, how do you want to proceed from here? I don't know how long the demo is going to take, but do you want to go and show us some things, and then
Yeah,
we have other questions afterwards?
yeah,
Uh,
sure. Yeah, absolutely. Yeah, I got a bunch of the demo today, but just feel free to chime in and interrupt me anytime if it's something comes up, and I just stop the demo, and then because I have already published a lot of demo on my YouTube channel. Okay, so I'm going to share my screen first, and then just real quick. Okay, yes, you guys see my screen?
Yes.
Okay, perfect. So today demo really we talk about the zero to hero in the Kubernetes native Java thing. So as I said, I'm developer advocate and Red Hat, and then you guys bunch of the contact information, my Twitter and the binding URL Daniel TV, and my GitHub repository. Just feel free steal any source code from my Git repository. So here's one slide for today. I'm going to really talk about and showcase like a live demo thing. So the Quarkus was born after Kubernetes, and then we got a bunch of stuff how to make your daily life better and easier. So for example, we minimize the dependency when you run Java application and small memory footprint, and then super fast startup time and response time. And we also have a bunch of the Kubernetes extension. Also, you can understand one of the Maven dependency. And then we put in that kind of stuff. So it will allow Java developer incorporate Kubernetes manifesto. For example, if you want to refer to Kubernetes secret or config map, you just put in that kind of key and value into your application property file or YAML file. It automatically Quarkus bind your information from config map or secret into your application like a reference string. So there are more deployed Kubernetes and how make it easier, change or evolve your application, add a serverless application on Kubernetes or any serverless platform. So I'm gonna try to get to my demo thing. Okay, so here's one more thing.
That's a nice guitar, by the way. I don't know if it's yours, but
What's that? So can you see my screen still?
Yes. Yep.
Okay. So here's Quarkus.io. Maybe I'm going to a little bit zoom in. Okay, here's Quarkus.io. Anyone interested in Quarkus stuff after this webinar? So just feel free to go to Quarkus.io. You can find all resources. So we have just released Quarkus 10. And then you can find the get starting and guide. And then when you go to guide, you have so many different use cases how to get started Quarkus application, like a getting started, a reactive application, and how to build native executable file. And then when you click on like a cloud, and then you can find that there are so many Kubernetes stuff here. So how to deploy Kubernetes, how to connect to like a messaging broker and so many stuff here. And then you can also click and start coding, just like a Spring initializer. Instead, you can start application creating project here. You can check in whatever you need dependency and the create to generate the application. It automatically download the zip file and you just extract and then just starting your application. But today I'm going to a little bit try to use a different way. So I'm going to use a Quarkus CLI, and then Quarkus CLI allows me to make it shorter, like a Maven command line or Gradle command line, and then it allows me to more the developer experience, good experience. So for example, I'm going to create a new Quarkus project, like a Quarkus, create a new application, for example, project name Kubernetes native Java. It automatically create a new project as a red bunch of stuff like a Maven wrapper, and then some Docker file in case you packaging application as a container image and deploy Kubernetes. And also their sample application. So I'm going to open my project using my ID tool, which is the VS Code. So I'm going to make it a little bit bigger. Just let me know.
So VS Code supports Java as well?
VS Code is open source tool, ID tool, like the IntelliJ or Eclipse. So you can usually use VS Code for Java application development, but also you can use this to any application development, like a JavaScript, Go, and Python or PHP.
Yeah, so I guess that was the Red Hat extension that allows, for better support
Yep, yep, absolutely. So I actually use Quarkus extension here, and also you can add like an OpenShift connector here. For example, once you add the OpenShift extension, you can find OpenShift logo here, and then once you click on here, you can go to log in OpenShift cluster and then deploy OpenShift directly. For example, behind the scene, this isn't actually not related to Quarkus, but you can create any resources on OpenShift cluster as well as Kubernetes, like a service or a deployment, etc. Okay,
Nice.
so here's my application just generated. And then when you go to a Java directory, and then here's my sample application, like just hello world, like a API RESTful endpoint, hello, and the return hello from REST easy reactive. This is what I'm saying. So Quarkus built in reactive application by default. So that's why the just sample application less easy reactive, and then go to POM XML, and then this is the 29.2. A little bit. I did my Quarkus CLI a little bit older version, but this morning we released a new one. So once I upgrade my Quarkus CLI, it automatically generate race one like a 210. Okay, so here's POM XML if you are familiar with the Maven project. And then here's one extension, REST Easy. This Maven dependency makes my application, Java application, handled by reactive application. So always first thing is a Quarkus thing. So you just run Quarkus application as dev mode, which is totally differentiator than any other Java framework. So when you run the Quarkus application as dev mode, and then you can keep changing application, we can say live coding mode. And whenever you change the application, it automatically recompile, rebuild, and restart your runtime environment automatically. It totally accelerate your developer productivity as a part of the inner loop development process. So as you see, your application is running. When you press W from it in the runtime environment, it automatically open your browser, and this is a red page. And then, so when you click on the endpoint hello, and you can see your hello endpoint, and go back to terminal, and then I'm going to open new terminal, and then maybe I'm going to make it a little bit bigger, and then just try to local host.
I like your
Hello.
prompt.
Yeah. Do you have any question?
No, I was just saying I like your prompt.
Yeah.
In your terminal window.
Yeah. So here's just the same thing. And then one of the beauty of the Quarkus for developer, actually, when you go to here, it's too big. Okay, visit dev UI. This is one of the great feature for developer, showcase a graphical way of what kind of dependency you actually pulled in. So for example, there are already pulled in as part of the framework level and also developer level. And also there are compilation editor. When you add a new configuration into your application property file, it automatically will be shown up here. And then when you change it here, it automatically changes your local file system at the same time. One good thing is you can just figure out what kind of dependencies I already have on my application. Sometimes you forgot it, and then you try to add the same dependency, like a duplication. You got some error, maybe some kind of you have duplicate dependency with a different version, which is sometimes called some kind of unexpected error. So go back to dev UI, and then one thing interesting in the terminal window, and here you can see the press R resume testing. When you press R, it kicking off continual testing capability. Everybody's saying test-driven development is super important thing for developer as well as the QA team. But a lot of developers just skip it because I don't have time set it on my continual testing environment. Instead, we have such a great CI/CD pipeline. But the problem is just sometimes the developer still human. which means you got some error or a mistake on your local file system, and then just push that code into Git repository. And then due to your fantastic CI/CD pipeline, that application automatically packaging and deployed to production environment based on Kubernetes in next 5 minutes. We can say there's a time bomb. It will be just boom after 5 minutes, and maybe sometimes ruin the entire system because the application properly or the code only working on your local environment. So if you could have like a continuous testing capability on your local file system, you 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 don't have any chance to ruin entire system on Kubernetes as well. So you can see all testing in just path. When you go back to WI, and then you can open here command. Is the read-only UI. You can see the same logs, and then you can see the old test result is just success. So what if we go back to ID tool and go back to here, and let's change the return code like welcome to level up power with Kubernetes, Java, and Quarkus. Okay, I just save a file, and then back to the terminal, and then you gotta add an instantly. And then when you go to here, so here just the actual the return code. I just changed the code like welcome to level of hour with the Kubernetes, Java, and Quarkus. But the expected here because when I go back to my application, here's my test directory. I already put the test case here. So test case is expecting this result, original one. So one thing, when you go to WI, and then you can see the same error here. So you didn't anything for continuous testing. It automatically showed up. Oh, you got some error. You just fail your continuous testing like a test-driven development. So this is a really good feature in like out of box on your framework, Java framework. So I just copy this thing and I back to IDE, and then I just change that. Okay, and here we go. The save a file, and then back to the UI, it automatically succeeds. And then back to the terminal, and I go to down, and you can find that it already succeeded. But in the meantime, I didn't even try to recompile or rebuild and even restart my application runtime. It automatically just happening, just like a JavaScript. It never happened in a Java world, but for Quarkus, this is one of the good, really good thing for Quarkus for Java developer. So this is, yeah, go ahead.
Yeah, I was gonna say this is a really nice feature because the inner loop, or the making it the time between your modification and the result shorter is really important for developers, and this is like just amazing in the Java world to have that capability like this.
Well, you're at DevOps Poland, and you think about so many of the premises that have come in with DevOps and the idea of pushing lots of changes out continually. That's actually where you start to hit a wall with traditional Java. Is how would you even do something like that sometimes? Whereas this is kind of the answer, because here we're taking a relatively trivial change, and it's operationally as trivial as the change itself. It literally just goes in without a lot of the other things that have to happen every time such a change is made in the traditional Java world. So that's pretty amazing stuff.
Yeah,
Yeah,
absolutely.
so that's the
yeah. Go ahead.
Yeah, that's the equivalent of hot reload or something like that. So
yeah, absolutely. Yeah, that's a really good point. Yeah, so yeah, I got some hands-on workshop this Friday. I'm gonna definitely bring this up as already to serverless and a lot of scripting with the Quarkus. So next step, I'm gonna a little bit more showcase. So we're gonna deploy this application Kubernetes, but so one of the big challenges for developer before they deploy application to Kubernetes, So a lot of enterprise application is not standalone. There should be communicate with some other external service, for example, database. And then, so for example, even Kubernetes. So a lot of people try to use a PostSQL database for store your business data. And then, so how to handle developer? Oh yeah, so most likely I don't have enough resources to install database on my local system. So maybe I prefer to refer to external database, or I most likely try to use in-memory database like HE2 database. But sometimes there are some gap technology stack between in-memory database and production database based on PostSQL into production environment. So Quarkus actually solved that problem with the dev services. So I'm going to add a few more extension here to JDBC PostSQL and Hibernate ORM. So Hibernate ORM is some kind of ORM mapper between your actual database schema and the Pojo Java beans. And then Panache is to make it easier for Java developer to creating data transaction and then like a DDL, DML based on Hibernate ORM. And the rest easy reactive Jackson is process and consume and produce your JSON file based on reactive application. So I'm just trying to use Coursera. You can actually add that kind of stuff. I'm going to change my right directory, and then you just run the Coursera. You can actually add the kind of XML stuff into Palm XML directly. So when you go back to here, Quarkus CLI, and then you can see the Quarkus automatically stop and then try to restart. In the meantime, you can see here's container image automatically start because we edited like a JDBC extension, which allows Quarkus to spin up the container image based on test container. So just try to Docker process. You can see PostSQL just start up and test container automatically start up. When you stop the the Quarkus dev mode, it automatically terminated existing running container image. So you don't need to Docker CLI. You don't need to do Podman CLI. It's automatically start up for developer. And as long as you have container runtime like a Docker, Podman, etc. Okay, so when I go back to dev UI and then dev services, and now you can see the Quarkus automatically set up your own compilation for database, like a password, and here's the DB kind and the JDBC connection, and then here's the username. And then it's automatically fantastic because when you go back to my ID tool, and then here is my resources and application property, there's nothing in there, just empty. But Quarkus automatically set it up by default because Quarkus expect, oh, you added a JDBC related extension, which means you're gonna start add a business requirement, how to store your business data into database. So let me try to add a real quick some interesting application here. For example, like a person Java for my entity. So I'm gonna expand the Panache entity here, and then I'm gonna make it this Java class like an entity here, and then maybe you can actually cacheable for high performance thing. And then I'm gonna create just a few Java attributes, which is the same thing to your database schema and the field. Let's say like a string, like a name, and also public string and then address. That's it. I just set it to you. And then the fundamental operation, for example, find the old data or the retrieve all data, which you normally for Java developer define and implement the kind of operation to retrieve your database. But the Panache, based on Hibernate ORM, wrapping and abstract that kind of fundamental operation for Java developer. So you have a pretty shorter Java class with the same functionality. So I just done, and back to the resources file. Let me try to add a few more the Java method here, like the get method, and then like a new path, for example, like a person, and then let's say try to produce a media type. I'm going to try to use JSON format here, and then the method name probably we're gonna try to return the list of the person, and like a list all, just retrieve all data from database, and then I'm going to return and the person and list all. That's it. This is all just to list all kind of Java API. Okay, so that's it. Let's try to create another method here, the same thing, but I'm going to try to find one specific data based on IDE, and then which will return one person Java class, and then let's say find by ID, and here is my long type ID, and then find by ID. This is the fundamental operation also defined automatically from the panache based on the Hibernate ORM, so which make really cool. So I just created two RESTful API. One is a person, the other person, and then ID parameter. And then let's try to. Yeah.
Do we have a list all function in the person class?
No, actually, when you go to person, and then I don't need to create the find all, find by ID or list all method here, because we just extend panache, and the panache enemy actually based on the panache base, and then it actually provide the bunch of the fundamental operation, like how to store data, how to create data, and how to delete it, and how to find. We can find this kind of stuff. Yeah, it's all abstraction. So one of the good feature of the Quarkus. And then I here to import SQL file. So maybe I'm gonna add some of the data here. Insert into the person values, and first the ID, like the next bell. And we're gonna actually using Hibernate, and sequence. And then okay, so and then my name is Daniel. And then I'm based on Boston, ELS. Okay. So let's try to make it two more, here with a Java. And where you're based on actually?
So yeah, Paris.
Paris. Okay. And then Randy, where's your base at?
Raleigh.
Raleigh. Oh, I love that Raleigh. Okay. So I just save a file, and then back to the terminal. And here's open terminal. Yeah, let's try to endpoint here, 80, and hello, and a person. Okay,
is it hello person, or yeah, nice.
Yeah, so we gotta enter the three, Japa, Randy, and Daniel. And then let's try to like number one, which is Daniel, should be Daniel, and then number three should be Randy. So this is what happening. But I just keep changing my code, even create a new class and a method, even SQL file, and then it's just happening. I don't even change. I don't even rebuild, recompile my application, but still, I just got all my database CRUD capability on my local application, which is stored automatically into my PostSQL container image running on my local machine. But even Quarkus stands up that PostSQL container automatically for me. So this is really cool stuff for local environment. And then now I'm going to try to deploy this application into OpenShift cluster, which is Kubernetes. But today I'm going to try to use developer Sandbox here. So just in case anyone has heard about the developer Sandbox before. So developer Sandbox is like a free offering for limited day, like 30 days for developer to give some chance to try some kind of Kubernetes experience. So when you just go to developers at redhat.com, you can just sign up for free, and then you will get immediately developer Sandbox for next 30 days. and then you can have a single OpenShift cluster based on Kubernetes, and then you can have a bunch of the like code-ready workspace, which is a cloud-based ID tool based on Eclipse Che. We're gonna change it a little bit for the soon, like a OpenShift dev space in case. So, and also you can deploy application to develop a sandbox for serverless application because we already install OpenShift serverless operator on top of the developer sandbox. So here's my sample application and the sample project, the DOH-dev. You can see no resources applied. When I go to terminal and I just check I'm in the right namespace, DOH-dev, which is good. So but for that, I'm gonna try to add extension, OpenShift extension, which allows developer packaging application and deploy Kubernetes or OpenShift or serverless on Kubernetes Knative. You can select it. So this is the one of the extension and Quarkus feature make you deploy application to Kubernetes. So back to the ID tool. And now I'm gonna go to my, where is that? Not here. And then resources file and application property. Here we go. So here's an empty. I don't even add anything for local environment. So now I'm going to deploy application to Kubernetes, which is a developer sandbox. In order to that, I'm going to add some form of few compilation. For example, actual database compilation. In order to that, I'm going to add the DB kind and PostSQL. So automatically generated. Okay, I'm gonna add the PostSQL. Let's say the database schema name person and database the table name person, and I'm gonna create a drop and create a new database, and then I'm gonna use the username.
So
Yeah, go ahead.
yeah, was this a VS Code snippet that you used, or?
Yeah, as long as you create a Quarkus project with the VS Code or IntelliJ, it automatically generates this compilation once you add the Quarkus extension.
Very nice.
Okay, and then load script. Okay, so SQL load script, we're gonna use SQL. So this is all kind of the
Initialization.
yeah, to initialize all the database. And then one thing we're gonna do that in Kubernetes compilation for deploy. So we're gonna deploy Kubernetes, yes, and Kubernetes deployment target, which is OpenShift. You could say Kubernetes if you want to deploy vanilla Kubernetes, and then expose the OpenShift expose, which allows to create a router to access your endpoint application by externally. So this is the automatic created router in OpenShift cluster. And then another thing is the deployment like a client and trust, not the self. Certificate. What is that?
Yeah, for the SSL.
Yeah, testing. That is the yeah, that is one. So basically, the developer sandbox use self-certificate the SSL TLS termination. So we're gonna set this true, and then one last thing is the OpenShift build strategy. You can use the Docker. Okay, so I think I just set it all, and then back to the here, and then I'm gonna try to use in Quarkus CLI build. And then I'm going to skip the unit test because I already just went through my testing scenario using the continuous testing. So this behind the scene, the first step, we're going to packaging application, just normal job file running on JVM. And then it packaging container application. So in the meantime, we actually need to create here the database. Go to OpenShift console, and then we're gonna deploy PostSQL. Here we go, at Pomo, and then create a new database, and then the service name person, and the username user, and then it's a super secret, just like we set it up the application property file, and just create that. And then it automatically start new PostSQL data, and then just for fun, you can actually add a label, because sometimes you got to deploy a lot of the application into same namespace. So if you could differentiate the application with some nice icon and or logo, and then it will be super helpful. You can just figure it out. Oh, this is some kind of application database, and then this is the Spring application or Quarkus application, something like that. Okay, so my Quarkus application just starting, and then I'm gonna make it a little bit bigger. Make it bigger. So it's a Quarkus, and then when you click on the Quarkus application pod, and then okay, it's server is working. So let's go back to maybe. Okay, so it should be somewhere. Maybe I'm gonna really start the create a database. So let me try to restart the container here. Just kill it pod, and then it automatically start a new one. One of the beauty of the Kubernetes. And then go back to here. And the own user PostSQL server process. Okay, back to the here. Oh yeah, the database. Oh yeah, I just did. I'm just putting the wrong the rows. That was the database. This is your Quarkus. So go to here. So as you can see, there are rows. Just automatically, we just created 3 data: Daniel, Japar, and Randy.
Mm-hmm.
And then when you go back to topology view, let's check it out. The route URL. I just copy the URL and then back to the terminal. And then here we go, and then try to access the hello. And then we got the same result, just like local. And then welcome to Red Hat Hour with the Kubernetes, Java, and Quarkus. And then like person, we got the error ID. Got a person. Hello. Oh, that's weird. Okay, let's try to take a look at the bureau.
Live demo.
The fail to see that HTTP cast. Oh, it's weird. Back to here. Any questions so far?
Actually, we do have a question while you're kind of poking around there.
Okay.
Mbal8 said, are there any plans to implement Quarkus AWS Lambda-like libs for GCP Azure? Thanks.
So you mean just deploy Quarkus application as a serverless on Google and Azure function, or something else like a native compilation thing? So
we're going to have to wait for Anmal to clarify his question, perhaps.
Okay, so here's the thing. So we actually couple of extension for Google Cloud Platform and Azure function. So when you go to quarkus.io and then go to guide, and then for example, here's a funky. So you can see the funky is one of the Quarkus extension allows developer writing code once and then deploy the same application code into multiple serverless platform based on portable serverless function. So for example, sometimes you need to rewrite your application to deploy Amazon Lambda. because you need to use Amazon Lambda SDK or API.
Yeah.
However, the Quarkus Funky allows you just write a code one time and then automatically deploy the multiple serverless platform Amazon Lambda here, and then the Knative and Kubernetes, and then the Azure function, and then Google Cloud Platform as well. You only thing add
sorry, Stephanie, can you zoom on Daniel's screen, please?
Click on which one?
No,
We're just reorganizing the screen. There we go.
Thank you.
Oh yeah, okay. Is that good? Okay.
Yes.
So as you can see, Azure, Google, and Amazon, only thing you need to set and define your target environment. For example, this is Amazon, this is Google, this is the Azure. And then the rest of them, the Quarkus will take care of that and deploy the same application with the different packaging stuff or different, all the SDK or API that provide the public cloud provider, the Quarkus wrapping up and abstract that thing automatically, create some of the G file or a bash script under target directory. So this is today Quarkus provide some of the Google Cloud and then Azure function and Amazon Lambda thing. Okay, so go back to here.
So this is really nice because am I understanding correctly that this is like an abstraction, like a common abstraction to the main serverless providers, which are Lambda, Google Cloud, and Azure functions. So you write the same code once, and then it can leverage the function capabilities of the cloud provider.
Yep. Okay, now here we go. So I think I figured out. So the Quarkus startup before the PostgreSQL starts because I got some too much talk and then before I create the PostgreSQL. Okay, here we go. So I just call the REST endpoint person, and then you can see, and then with one parameter and Daniel and just wrong parameter, and then the ID3 Randy and ID2 is a Jafar. So this is exactly same feature and the same result of what I got in my local file, and then I just deploy the same thing in the Kubernetes, and then it's totally working because I already used the container environment. I already some kind of stuff, but in order to have the same capability on your local machine, from your local to the remote Kubernetes, you got a lot of stuff to set it up on your local and even like a Kubernetes side. But the Quarkus making your life easier, like a developer life easier with that kind of capability. So one thing, how many times do I have? Maybe I can just real quick to showcase the neighbor compilation at the moment.
We have a little bit of time.
Okay, so cool. So go back to ID2. Maybe it's sometimes neighbor compilation pretty wrong. So okay, so maybe I can show another thing. So I can have two things. So one is native compilation. The other one is secure this application. Which one do you prefer? Okay, so
I think go ahead. Yeah, I think go ahead with the native compilation.
Okay.
And show us the startup time or something like that.
Okay. Yeah. So let me just make it simple. My application real quick. Just for in case to make it faster. So just go back to the original application here, and I don't need to SQL file, and then I don't need to all compilation here, and then I don't need to unnecessary dependency. Okay, that is the file. Okay, and then back to the terminal. And then I just start my local environment, and let's try to build and skip test. It's originally just a packaging application as Java file, and it takes some time, depends on how much you have logic, and then just go to target directory, and then here is the Quarkus app directory, you have the runnable Java file here. So
Okay.
but for running that application, here's my active monitor and here's a memory, and then like a Java. Okay, I'm gonna make it bigger. So I have already running a few job JVMs. So the last one 62 and the second last one 155. Okay, so just remember that. And I'm gonna using the Java, the traditional way to run Java target and app and then run. Okay, I just run the application and then you can see it's running on JVM, and then it takes almost less than 1 second. So if you start maybe second time, it will be maybe really faster. So you can see for almost same thing. So let's just here we go. Less than 1 second in the JVM, and then back to the active monitor. Now we have a new JVM here, 88.7 megabyte. And then when you go back to here and then try to call the first response time, which is like a really consume
Hello.
memory, then it just same capability and back to activity monitor, and then it will really show at and then 93 from 8080. So less than 100 megabytes, but just imagine that you packaging this application like a 88 memory footprint, but sometimes you need to scale up this application maybe 100, which means there's so many memory consumption, which is why a lot of developer, Java really heavyweight on Kubernetes for scalability. So now I'm gonna go to here. I'm gonna stop the runtime and try to packaging one more time and the native. So the Quarkus application on the Palm XML automatically edited native profile in the bottom of the Palm XML or Grid as well. This profile allows the Java developer packaging application as a native executable file based on the ahead of time compilation strategy. It takes some time. For example, it will packaging application as a Java file, and then it based on using GraalVM and the packaging executable file, and then it takes some time. And then, so for example, I'm using pretty old Mac OS, so sometimes it takes more 2 minutes or 3 minutes to packaging this application, which is just pretty simple. But when I try to packaging application, same app on the new Mac OS, like a M1 process, it just takes 30 seconds to finish the packaging application. So it totally depends on what kind of machine you are using and then how many application code you are implement to packaging application. So I would say you don't need to packaging native compilation every single time whenever you change the code. So this is
Yeah.
only for production
Probably.
environment. Yeah, and a specific use case, for example, like a serverless application or pretty lightweight, like an event-driven application, rather than all kind of application. You can also put this like a Maven command line or Quarkus CLI for native compilation as a part of your CI/CD pipeline, like a Tecton pipeline or a Jenkins pipeline. So you don't need to do every single time on your local machine. The reason why I try to showcase this kind of stuff, I just want to show how it works and then what the native compilation looks like. So this is just running on my local, and then it only run on my local operating system, because when you packaging this application executable file, which format depends on your operating system. For example, when I create the native executable file based on Mac OS, that file format based on Mac OS, it can be running on Linux operating system. But you can set one configuration file like a key and value, and it will packaging Linux format. So I just took it took little bit more 2 minutes, and then when you go to target directory, and now you can see in the executable file there are no extension. How to run? Just run that file directly. And when I run that, you can see here the native, and then the runtime is 22 milliseconds. So previously, we almost 1 second less than 1 second, like a 950 millisecond. So we have a 22 millisecond. It's almost 40 times faster than existing Java application. And then when you go back to app monitor, and then let's change to runner, and then here we go, 8.7 megabyte. Previously, we have 88. It's 10 times less than memory footprint. So go back to here. So let's try to call the same endpoint. Let's put UI, and that's the functionality works. And back to here. So a little bit increase the memory consumption, 9.6. It's still 10 times less than memory footprint. Just imagine that you just deploy the same business application with the native compilation, and then small memory footprint, it always relate to your money, like the container image size, which is related to your network bandwidth, also your like a PVC, like persistent storage, as well as, so sometimes you need to scale up from 1 to 10 or 1 to 100. You need to maybe it takes more than 5 minutes, but it just maybe 5 seconds. Which packaging, which framework you want to use for your Kubernetes environment? That's we can call set Kubernetes native Java with Quarkus. So this is how it works. And then once you deploy this native executable file, so when you add the OpenShift extension I would showed earlier, and then you can run the same Quarkus CLI or the Maven command line. And the for example, Maven command line. So Maven clean package, and then you just use the profile native. This is make the same happening. And then it automatically packaging native executable file. And then as long as you add OpenShift extension on Quarkus project, it automatically packaging application based on the Docker file when you generate Quarkus project. And the source directory, you can have a bunch of Docker file for JVM and native. And then it automatically packaging your application as a container and deploy to OpenShift cluster. If you set it up like an external container registry, like a Docker Hub, Kubernetes.io, or Google Container Registry, it automatically push the container image from local into remote container registry. And then you go back to Kubernetes cluster and then you can define like a YAML file, for example, deployment YAML file, and then it points to external container registry. It will pulling down that container image automatically into your Kubernetes worker node. Okay, that's all I have today. I think so. I'm really running out of time. And just one quick thing. So just here's my Bini URL. I already put in the old kind of demo tutorial, just like I showcased today. Just go to the Bini URL, Bini Daniel TV. There are so many tutorial demo video, and then just feel free to add some comment or question, and I'm more than happy to address your question after this webinar. All right.
Well, yeah, Daniel, that was a lot of information, and really a great walkthrough through Quarkus. You know, my team is actually moving a lot of things that we have in our infrastructure to Quarkus, and I have a much more visceral sense of why they want to do that and the benefits that we're getting out of it now. So thanks for all that. Jafar, did you have any closing comments?
I think that was amazing, Daniel. Thanks for doing that. And it was all live demo, so it really shows how to get from like very simple project to extending and adding new capabilities. And we see that Quarkus makes that a lot easier with all the accelerators there. You are very clever guy, but Quarkus helps a lot. So thanks a lot for doing that. It was really amazing.
And I'll add one last thing, which I've posted in the chat, is that we actually have a certification. Occasionally I have to pull that out, that I do run the cert program at Red Hat, and we have the Red Hat Certified Cloud Native Developer certification, which is in fact built around Quarkus, and we have training to support that. So if you're somebody who is new to this world, or maybe you're experienced in the Quarkus world and you want to be able to have that gold ring, definitely take a look on redhat.com. Follow those links that I posted in the chat. Daniel, any closing thoughts before we wrap up?
Oh yeah, you guys doing great, and then thanks for addressing the question, and then once again thanks for having me. And then I will be everywhere, so you can reach out to me directly, like
Ubiquitous.
Twitter and the LinkedIn and the YouTube channel. I mean, I'm already happy to meet you and talk about the Quarkus and CloudNet stuff. Thanks for having me once again.
All right. Well, thank you, Daniel, and everybody. If you enjoyed today's episode, please like, subscribe, and share. Let everybody know we're here so that, great guests like Daniel O continue coming and visiting and giving us demos of all these technologies. So with that, thank you for joining, and we will see you next time.